The first place I want to begin is with time windows. So there are windows of time that the human brain utilizes to make sense of the world around it. And most of the time, young engineers or inexperienced engineers do not take enough time to understand how the brain processes sounds in real life as a way to understand how to manipulate that later. So I think it's important for us to just take a minute to look at these windows of time and figure out what can we do in our productions that utilize these bits of perception. Now, it all boils down to this idea that our brains process sound at a speed. So we have about a range of about 10 milliseconds before the brain is able to take sounds that arrive at the left ear and hear them as separate sounds from whatever's arriving at the right ear, which means that there is this entire range of time that exists smaller than that the brain uses to understand location in a space. So in other words, if a sound arrives at my left ear and the same sound arrives at my right ear, but 7 milliseconds later, my brain can't hear those as two separate sounds. It hears it as one sound because there's not enough processing speed in the brain for it to make sense of that sound in real time and then say, okay, I've figured out what that is, and now I have enough time to figure out what this is too, right? In a way, it's like someone's tossing you balls to juggle, but you can't juggle that many balls at once. So the whole thing just kind of falls apart, right? So your ability to identify sounds is limited in duplicity, at least, to 10 milliseconds. Less than 10 milliseconds, the brain is summing those sounds together, and it's the subtle cues that are created from that summing that tell the brain where something is. And this is something that begins in the womb. It's something that we inherently know and learn how to do, but we can understand directionality simply from what we hear, not just from what we see. And this ability for us to understand directionality from very small delay value times is what we call binaural perception. Now, the average human being has their ears somewhere between 6 and 7 inches apart from each other. And that's a constant. Your ears never get closer together or further away in a single day or a year or a month by any meaningful amount. This is not a variable thing. It's not as if we can stretch our heads apart and push them together to change our binaural perception. So these become constants to our apparatus. Our brain is processing audio information through the same ears your whole life. So these things are static. So that means that the way we process sound is going to be consistent with the spacing between our two ears. Now, just to review the basics of binaural perception, sounds that are directly in front of us will arrive directly at our nose and splay across our nose to both the left and the right ear. And the arrival time of that sound in the left ear will equal the arrival time of the sound in the right ear. And this causes us to perceive that that sound is directly in front of us. And this is exactly why when you have two speakers that are putting out the same signal, we hallucinate a speaker in between them acoustically. It sounds as if the sound were coming from directly in front of us. That's because the sound is through those two speakers is arriving at the same time at both of our ears, and it's arriving at the same amplitude. So if left and right are equal in amplitude and time, we perceive it to be directly in front of us. Now, if that sound were to shift to one side, then things change. So in this case, this sound has shifted to the person's left, which means that that sound will then arrive at the left ear slightly ahead of the right ear. And if the sound were on the opposite side of the head, those values would be opposite, right? When one value becomes higher on one side or the other. This gives us our lateral perception. I talked about the speed of sound as being the constant. In this case, if our ears are indeed 6 inches apart, we could assume that 3 inches to the left ear, 3 inches to the right ear, that's a constant, right? So if sound arrives at one ear sooner than the other, we also should assume, since the speed is the same, it's not traveling faster on one path to the right ear than it is to the left ear. They're traveling at the same speed. That sound must be then traveling a further distance. So distance is tied to delay, and delay helps us to perceive directionality.
All right. I hope you enjoyed that clip. If you want to view the full Mixing Essentials course, click the link that's on your screen now to learn more about becoming an Audio University member.